we have established that if this is correct, then once the experiment is done, if this is correct, the values of theta and the values of p, if you find the logarithms, the graph of ln theta against ln p should be a straight line. That is why now we talk about plot a graph of ln theta against ln p. You see, after saying plot such a graph, in as much as I then did what I did below the run, I then come and say the relationship is valid if the graph is a straight line. So in other words, we are saying that the relationship between theta and p follows that equation which says theta is equals to k sigma p to the power of q. If the graph that we draw is a straight line, you see, because now if you draw a graph of ln theta against ln p and it is not a straight line, then it means that that relationship is not valid. The relationship theta is equals to k sigma p to the power of q. That relationship is not correct if the graph is not a straight line. Now, provided that it's a straight line, then it means that we should be able also to find who is q. And as you can see here, q corresponds to the gradient m. So to find q, as they wanted us to find q, we will find the gradient, and by finding gradient, we define q. Then next, c corresponds to ln k sigma. So if c corresponds to ln k sigma, c is the y-intercept. Y-intercept is equal to ln k sigma. Then to remove ln from both sides, we say e exponential to the power of ln k sigma, exponential to the power of y-intercept. But if you do exponential to the power of ln, it removes ln and we are left with just k like that. So k sigma. So, but the other side will be now exponential to the power of y-intercept. So then how do you find k? K then is equals to e to the power of y-intercept divided by sigma, because the goal was to find k. And k is the density as measured and calculated, as we talked about. So now you have done the experiment as it is needed to be done. Finally, you have to talk about safety precautions that may need to be done when you are doing the experiment. Safety precautions, remember, they are meant to protect, number one, the experimenter, the one who is doing the experiment, and also to protect, number two, the one who is going to be the apparatus themselves. We don't want to be damaging apparatus themselves. So perform the experiment inside the safety screen to protect for the event of a pressure explosion. Remember, you're boiling salt solution here in a sealed container, and this sealed container might be a conical flask, it might be a glass container. You see, it is sealed, it might be sealed, but the fact still remains that it can actually explode under the pressure that might accumulate inside there. So to prevent the situation whereby it explodes and hot water comes flying into your face, we do the experiment inside the safety screen. Then the other one, use protective gloves to handle hot salt solution, because after completing the experiment each time, you might need to throw away the salt solution so that you put another salt solution again, which is too cool, which has not been used already. So in this case, you need to handle the conical flask, you need to handle the glass, in which case you need to be wearing gloves because it will be a hot container. So this is the end of this question.